Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 108. Convert sorted array to binary search tree. You want an integer array nouns where the elements are sorted in ascending order. Convert it to a height balanced binary search tree. So they are asking us to find the height balanced binary search trees. Okay, one height balanced binary search tree is a binary search tree in which the depth of the two subtrees of every node never differs by more than one. So what it states. So let us understand this. If we have something like this, okay, something like this. Now, if I say for each and every node, the height difference between its left side and also towards right side should be what? Less than or equal to 1 at most. At most it can be 1. Okay, let me take this node. Okay, for this node, what is the height of this left subtree? It is 0, right? Okay, what is the height of the right subtree? It is 1. So 0 minus 1 is what? Minus 1. So taking the absolute difference between them is 1. So it is less than or equal to 1. Okay, if I am here, okay, what is the left subtree height? It is 2. What is the right subtree height? It is also 2. So I can say 2 minus 2 is equal to 0. So it can be so an balanced binary tree. Okay, if I have something like this. Okay, now what's the height of the left subtree? It is 2. What's the height of the right subtree? It is 0. So I can say it is 2. So I can say the difference between right subtree height and the left subtree height is less than or equal to 1. No, it is greater than 1. So I will say what? It is a false. It is not a height balanced tree. Now hope you understand what is my height balanced tree, right? Now, in question, they will give an array like this, and we want to give something like a binary search tree, a PS tree, that also should be what? A height balanced. A height balanced. So we already seen what is meant by height balance and what is meant by PS tree. It means a binary search tree in which there are two property. What are those two property? For each and every node, the left subtree, the entire left subtree is what? Is less than that value of that node. And for the right subtree, the values are greater than that of the node. So it is greater. Can you understand this? So these two are the property of this BSP. Okay. So we have this is our list, right? This is our array. Now we can consider any type of BSP with the height balanced tree. So one of the possibility is like this. So 0, minus 1, minus 10. Then here 5, 9. What is signifies? Here is 0, right? Okay, what is the left subtree? It is minus 3 and 10. So minus 3 and 10 are what? Or less than the 0. Okay, 5 and 9 are what? It is greater than that of 0. Can you understand this? Yes. Now similarly for this minus 3, what is my left subtree? It is minus 10. Minus 10 is less than minus 3. Okay, for this 5, 9 is greater than the 5. So that is the right subtree. It is in a right subtree. So similarly, I can construct like this and also this. So we have a minimum of 3 combos, right? I wrote just 3 combos. We can also do some combos like this. Okay, so I can say we want to return any one of them. We want to return any one of them as our result. Hope you understand this. So this is our problem statement. Now, how to do this? Okay, this approach is straightforward approach. We are going to do what? A divide and conquer rule. Okay, in this divide and conquer rule, we are going to do what? We are just picking the middle element. Why we are picking the middle element? You may ask. Why we are picking the middle element? Any purpose? Yes. If I pick this middle element, I can say the left subtree will contain what? A 2 value, and the right subtree will also contain a 2 value. Or else, take for example, sometime it is like this. It is like this. Now, if I take the middle value, what is the middle value? I can say the middle value is minus 3. So that's that my left subtree will be of 1 and my right subtree elements of 2. So at the most, I will be getting what? A 1 difference, right? Can you understand this? We can get at the most 1 difference. So that's the reason behind this. We are using what? We are taking the middle element and using this divide and conquer rule. Okay, let's get started. First of all, we are going to take this middle element. So let us take this as our example. Now I am going to take the middle element. Okay. Now again, I'm going to find what? This is our right subtree. Sorry, left subtree. So left subtree elements are what? Minus 10 and minus 3. Can you understand this? Okay, hold on. Again, from this, what's the minimum value? I can say this minus 10 is a minimum value. Yes. So put minus 10. Can you understand this? Sorry, middle element. Middle element is minus 10. Sorry, this is a middle element, right? Okay. Now, after this, what is my left subtree? My left subtree is something in my left side, right? And my left side of this minus 10. Because, see, this is what? This is the ascending order. This is sorted in the ascending order such that elements left value. If we do take any elements and its left value will be what? Is less than, and its right value will be what? Greater than. Can you understand this? That's the maximum possibility we have in the ascending order, right? So I can say I don't have any left value. So I will do what? A null here. I will insert a null. Okay, what is in the right value? Okay, I have a -3 around, right? Okay, put -3 and send the left and right value. So the what are what? And null. So I can say this is my left subtree, right? Now, when I'm going to a right subtree, it is what? 5 and 9. Other elements, right? Other elements. Now, again, what is the midpoint? I can say the midpoint is pi, right? So, pi. Okay, put a pi here. Put a pi here. Okay, in pi, what is the left subtree? It is null because we don't have anything. We don't have anything. It is an empty array, right? In left side. Okay, in right side, what is the element? It is only 9, right? Okay, put a 9 here. Now, again, go for the left. Left is what? An null. And left, right is what? An null. Because it is odd. Empty subtree, right? Empty list. So, I can say this may new tree, PST, and also a height balance tree is formed, right? A height balance tree is formed. Can you understand this? So why we are taking the middle element instead of taking any random element? Because I can show that by taking the middle element, I can show that it is what? A height balance tree. Can you understand this? It is a height balance tree. And secondly, what we are doing here, we are just taking the minimum values and going to the left side. We are taking the ascending values, right? It is in ascending order, so we are taking the left values. Left value as left subtree, and also right value as what? Right subtree. So from this, I can say that it will be surely a BST because all smaller value will be going what? Going to the left side, and all greater value will be going what? To the right side. So I can say this will be what? This will be a BST. So this is the whole approach. And let us see what is the time constant in space times t. So tell me what is the time times t and space times t. So I can say my time constant will be O of n because I'm traversing this entire node, an entire array, right? I'm traversing this entire array to construct this BST. Yes, and what is my space times t? I can say space times t will be O of, I'm taking this hop, then hop, I'm taking this, right? And I'm sending and completing this whole subtree, and I'm completing this whole subtree. So I can say it takes a recursive stack space, which will be what? O of height of this binary tree. And understand this? Since it is height balance, it will be always the height. Height will be what? A log n. It will be at most a log n, and also beyond it, there will be no considerable change, right? So the height of this binary tree will be my space complexity. Since we are taking what? A recursion approach. Here we are using what? A divide and conquer approach, which is also what? A recursion approach. We are dividing the array into some parts and just doing some operation in it, and we are just combining it. That's it. So by combining it, it will be what? Full BST. Can you understand this? Fine. Now let us see the code. Code will be similar to this approach. Here, first we can see the exact code that I have written to the drawing definition. Then we can see what is meant by range. Okay. First of all, let us see here. Def tree of nums. Now, if not nums, which means what? If it is an empty array, then what should I do? I should return none. Can you understand this? Okay. And how to find the mid? Len of nums divided by 2. Simple, right? N of nums divided by 2. That's the formula to find the mid. Hope you understand this. Okay, now root is equal to tree node of nums of mid. So I'm creating a tree node for the nums of mid. That's what I done here, right? First I picked this 0 and created a tree node here, right? A node here, such that I am creating a object for this tree node class, right? Then node.write is equal to tree of nums of mid plus 1, then mid plus 1 to the end of that array. I'm doing a list slicing, right? So it tells what? It tells that I am here. My right side part will be the right subtree. I'm just taking it. Now, root.left is equal to tree of nums of just take up to what? Just take to the P4 element, which is not all left side element will be what? A right subtree. You can also interchange them. It won't affect, okay? You can also take this and put it here. First go for the left subtree, then go for the right subtree, or go for the right subtree, then go for the left subtree. It won't change, okay? Now, return the root at last. Why I am returning the root? Because at last, what we are doing this by this root, we are just keeping that left side, right subtree and also left subtree, right? So I am just returning it. Okay, now return tree of nums at last. So let me submit it. Yes, it is accepted successfully. Now let us see the next approach. In next approach, we don't have to create some subarray. Instead of that, we are taking a range. Okay. See here, initially def tree of L comma U, and if my lower limit is greater than the upper limit, it means what? My node exceeded. I don't have any node. further. I don't want to take any node further, right? So I will return it. Okay, mid is equal to L plus U minus L divided by 2. So this formula is what? A binary search formula, right? In binary search, we use to find the midpoint, right? So that formula I use here. Okay, now root is equal to 3 node of nums of mid. So I'm taking what? Nums of mid as our current node, and for that left, root dot left is equal to 3 of L comma mid minus 1, which is what? Currently it is mid, right? So I want to take the lower limit to the before value of my mid. And for right side, it is mid plus 1, the after value of mid, and towards the upper limit. Can you understand this? And just return the root. So we are just taking what? Instead of taking those subarray, I'm taking what? A range, L comma U, which means what? The subarray is index. We don't want the subarray. We want only the index of that array. Enough. Okay, and then return 3 of 0 comma length of nums makes 1. Just I'm sending what? A lower limit and upper limit. Let me submit it. Yes, it is submitted. Thank you.
The amount of dot